So what I'm supposed to do is that I'm supposed to first set up my OpenAI key, okay, and then I will be importing this OpenAI embedding model, okay. So which embedding model I'm supposed to use? I'm supposed to use this text embedding 3 large model, okay. So this is like the transformer based model which will do the embedding of my chunk, okay, of my all these 64 chunk. So all this embedding has been created. So if I just go to this embedding part, all this embedding has been created. Now what I need to do is that all this embedding I need to save it into my vector storage, okay. So in order to save into my vector storage, first of all I need to define that vector database, okay. So what I will do is that, like, let me go here, okay. So let me just go to this quadrant. Yeah, so just go to this quadrant part, okay, in order to just do the sign up operation and come to cluster, okay. And after coming to cluster, see, for every user, if even if you're actually using it for a free, so what you will do is that for every non-registered user, they have actually the very free credit of so 4 GB of disk size and 1 GB of RAM, okay. That is good enough for our use case, okay. So I will just go and create my cluster name, let's say verify, okay, and then I will going to create my cluster. So this is my Frankfurt, so this is my server located in some Frankfurt, okay. So this, my cluster has been created, okay, and this is my API key. This is my API key, and then this is the code I am supposed to use in order to connect my system, okay, with my cloud vector storage. So what I am supposed to do is that, because my embedding is already created, so what I will do is that I will be connecting these things, right? I will be connecting these things. So after connecting, so what I'm supposed to do is that this one, right? So quadrant client, okay, so this will going to connect my local system, okay, to your vector storage, okay. Now once these things is actually created, now you need to create a collection, okay. Just like inside the normal database you create a table, right? So even like for vector database, so it is basically the like a non-structured database, right? It is a NoSQL based database. So inside this you need to create a collection, okay. So instead of table you need to give the collection, okay. So I'm actually giving the collection name. So let's say that I will be like using the collection name in front of you. Let's say verify, okay, rag, verify traditional rag, okay, traditional rag, okay. And now what I'm doing here now, guys, please understand this. So first of all, I have the chunk, okay. I am actually having a chunk, okay. I already do the chunking operation, right? Which type of embedding I am doing here? I am actually like using the dense embedding, okay. Which embedding model I used? I have used the text 3 OpenAI embedding model, okay. So all these model, just in a one single line of a code, it is just like I can just put it into this method, okay. That is why quadrant seems to be very easy for me. That's why, like, and then this is basically the URI and this is the API key, okay. And these are the collection name, okay. And what is the retrieve mode? So here I can just give the retrieve mode as a dense retrieve mode, okay, because this is just a traditional rag. In enhanced rag I will be using the hybrid mode, okay, and then I will like share you that what kind of retrieval I'm getting, okay. So for this I'm just making a simple rag chatbot, okay. So now my vector storage has been created, okay, and all this embedding will be saved inside my vector storage. So let it run, and then let me show you the embedding. All these embedding will be saved in the collection name verify traditional rag, okay. So if I just go here, if I just go and check it, right, if I just go to quadrant, just refresh it, go to my cluster, just go to this cluster, go to this cluster UI, okay. If I go to this cluster UI, you will see that my verify traditional rag, this one, right, these two have already created just for creating my lecture, okay. This is the new one, right, verify traditional rag. This currently it has created the moment I run that sale, okay. So if I just go and visit inside this one, you will see that all these cluster, okay, like there are total 64 cluster, right. So for all this cluster, if I just go and extend it, right, see, right, so this is my, let's say, the first chunk, this is my second chunk, right, this is my third chunk, right. And all this chunk will be stored, okay. Other than that, like with the chunk in the metadata, what it will going to store, it will going to store the embedding also, okay. So that for every chunk there will be embedding, right. And in vector database you are going to surpass all this embedding mapped with the, let's say, the entire text chunk. I have already told you in my theory section, right, that in my vector database I will be storing the all the chunked mapped with the embedding, okay. That is why. So if you just go and find the similarity, so you can actually like find that there are so many words which are actually similar to this one, right. So similarly you can actually open the graph as well, and you can actually like going to see all these things, right. So let me just again revert back to the same code, right. So again, so after like creating the embedding, okay, now what I'm supposed to do is that again, so in order to get the collection name, I can actually get the collection name, right. So this is my verify traditional rag, okay. So this is my collection. So inside this collection I am actually saving all this embedding, right. Now let's define the retrieval part. Okay, so because in my vector storage, all this vector database, like all this chunk embedding, okay, chunk embedding pair has been already saved, right? So before that, I also need to define the retrieval, okay, so that whenever the user is asking any question, right, so it will directly, like after user query embedding, okay, it will go to this retrieval part, and then retrieval is going to take the user query embedding, okay, and on the other side it is actually connected to the vector database, and it will find the similarity check, and then it is supposed to give me the answer, right? So I need to define that retrieval, okay, and defining the retrieval is very easy because I just need to use this vector storage as retrieval. That's it. So this is my retrieval. So what I'm about to say is that this is my vector storage, okay, agree, this is my vector storage, so everything will be present inside my vector storage, right? And after that I just need to use, so inside this vector storage I need to call as retrieval as a method, okay, I need to call this as retrieval as a method, okay, so that I need to specify that what in my top k value. So my top k value is actually 6, which means that like when the retrieval, right, when the retrieval after taking the user query, the user embedded query, okay, when the retriever is going to search it into my vector database, okay, then it is supposed to give me top 6 most similar result, okay, that is why I've just put k is equals to 6, okay. So I have actually defined the retrieval. Now again, these are the very common parts. So at the very last stage of RAG, what I've already told you is that I need to define the prompt as well, right, a chat prompt, right, just to give my LLM model as a suggestion, right, because after retrieval the chain actually go to this LLM model, right? So inside the LLM model I need to give the suggestion, right? So this is just a setting up the LLM model, okay, just same thing, right? These I have already like told you and showed you the implementation of this in my previous lecture as well, right? Now let me going to ask any question, okay, let me going to ask any question that list out the limitation of AI surveillance camera. So let me just going to ask this question. So what it will do is that, again, this is basically the user question that user is basically asking, right? This question has to first go to the embedding, okay. Now the entire question, right, these many number of word, I think 14 to 15 number of word in the one sentence, okay, it will go into the embedding part, okay, it will get embedded, it will convert it into like the numeric format, it will go to this retrieval, okay, retrieval is going to take these things, and then retrieval will supposed to match the similarity check with these, right, with these many different chunks, okay, and it is supposed to fetch the top 6 chunk, okay, with the highest similarity score, okay, and based on that it is supposed to give me the answers, okay. So all this top 6 chunk, okay, all this top 6 embedding, okay, because in my vector database there is a embedding as well as chunk pair, okay, that every embedding is actually paired with the my text chunk, right, I have already told you, right? So now what is happening is that it is supposed to fetch all these top 6 retrieval, and it is going to pass to my LLM model. It is directly not coming to us, okay, it is going to pass to my LLM model, so that I have already instructed my LLM model that answer based on only context, okay. So that LLM is actually like taking all these top 6 retrieve chunk, and then with this it will try to synthesize my response, and it is actually giving me these kind of a response, okay, that this is my response. Suppose that if I'm going to ask some other question that like, and these questions are actually asking relevant to this data, like these are my data, right, info.txt. So I'm just asking this question, right? So let me just suppose to ask that what are the rule-based strategy of AI, or what are the rule-based strategy of AI in behavior analytics, right? So let me suppose to ask this question that what are the strategy of AI camera in behavioral analytics, okay. So based on that it is supposed to go and check my top 6 relevant chunk, and then again give it to my LLM model, and based on that it is supposed to give me the response, okay. So yeah, based on that it is supposed to give me the response that key strategy of an AI camera using the behavior analytics is these things: self-learning, continuous classification, feature driven observation, right? So all these things, right, and it is actually giving us the point by point. So in this way any user can basically try to ask any question based on your relevant data, okay, because see, first of all, and this is just a traditional RAG, okay. So again let me revise what I have already told you. I have actually using this text loader, so that once I actually uploaded my document, text loader will going to present like whatever the text which is present inside my document, it is going to load it into the document object. After that I am supposed to use a recursive text splitter, so that whenever I am doing the chunking operations, I will doing the chunking operation with the chunking overlapping strategy, okay, so that my chunk fabrication is there, okay, so that the semantic meaning is actually present, okay, I'm not losing the semanticity. That is why, okay, and after defining each of these chunks, then I will be using the embedding model, okay. So I am actually like using this OpenAI embedding model, which is like text embedding 3 large model, so that for every chunk my embedding will be created. Okay, and once this embedding will be created, then what will I do with that embedding? I will going to proceed by saving this embedding into my vector database. So in order to save this embedding into my vector database, I need to create a vector database instance. For that, I have actually using this Quadrant as a VectorDB storage. Okay, so for every user, it is actually supposed to give you 1 GB of RAM and 4 GB of storage system. Okay, so inside that I have already initialized my cluster. Okay, and then I have already connected my local system, okay, to my cluster, okay, to my vector database storage. Okay, and in that I'm just supposed to give this document is equals to chunk. Okay, which means all the 64 chunk will be present, will directly go in here. Okay, and then with every chunk, okay, the embedding has been created. Okay, so for every chunk, this embedding I am going to pass it over here. Okay, I don't need to write extra like code for that. Okay, it is all taking all in one go. Okay, then again I'm creating an API key, giving this API key, and then finally I'm supposed to use this vector storage in order to create the retrieval. Okay, for retrieval creation, again it is very simple. Okay, because once it is vector storage, then at the very second last phase of RAG, I need to create the retrieval. Okay, I can just create a retrieval using a vector storage as retrieval method. Okay, and once while creating the vector retrieval, I just need to specify that how many top k relevant result I basically need. Okay, and after that I need to define the LLM model. Okay, so that I can actually like give my prompt, so that all this retrieval part, instead of directly going to the user, it will just synthesize this into the LLM system. Okay, and then like format our output in a very good and smooth response, and finally I'm getting this response like this. Okay, and this is just a traditional RAG. Now let me tell you one more very important thing, okay, which is basically the runnable pass-through. See, what I mean to say. Okay, again I will try to make the another set of notebook. I will try to create another set of notebook just to explain you the runnable pass-through, but I'm just telling you more theoretically that what is basically runnable pass-through. Okay, for example, let me just create a one more notebook, or even like in this notebook you will understand. See, okay, I'm writing it here only. Okay, so now see the runnable pass-through. Okay, what is this runnable pass-through, and what is this runnable memory? Okay, what are these things? Okay, see, whenever actually I'm using the runnable pass-through, okay, so it is just a one of this LangChain tool. Okay, this is actually the one of this LangChain tool. Okay, and why it is basically needed? Okay, why it is needed? Because you know about these chains, right? Inside this chain, suppose user is actually asking any question. Okay, suppose user is actually asking any question. Now you know that in a chain, along with the user question, okay, there are other things also present here. Okay, like LLM is there, some prompt is there, right, and some, let's say, previous information is also there. Okay, previous info is also there. Okay, or some instruction is also there, like a system prompt, something like that. Okay, so and then like the chain is getting completed. Okay, and then like the chain is getting completed, and then when the user is actually asking chain dot invoke user question, like user query. Okay, and then it is supposed to give me the response. Now while giving the response, right, in order to make the user question much more individualistic, now what does that mean? It means that I don't want my user question to get manipulated, so that next time if I'm supposed to use this chain.invoke method, right, and suppose if the user is asking question second, right, so I don't want that question second to get manipulated by the previous chain response. Okay, I want the user question to completely adherent. Okay, I want user question to completely like untouched. Okay, so that it will work in a very clean way. Okay, I hope you are getting it, right? So that is why it is always a good practice to like use this runnable pass through. Okay, so that I wanted to show you. So even if like I have actually asked the grok model, so it has also tried to give me the same example. So if I just go and walk you through this grok example, so I think you will understand what I'm supposed to say. See this one, let me increase it. See, so this is actually the runnable pass-through. I basically asked, right, that what is this runnable pass-through, and I see that a lot of people are actually using this runnable pass-through. Okay, so why is it actually needed? So just understand this thing. Okay, that why is it actually needed? Because passes the input through a unchanged. Okay, like if you want your user input to completely unchanged so that it does not manipulate. Okay, so it is always better to use this runnable pass through. Okay, so just read with me, like what is this? So passes the input through unchanged. Okay, or adds or slash modify the key in a dictionary. It is like an identity step in a chain. Okay, useful for keeping original data while branching or adding the new information. Now this is very important. Okay, because in chain you basically add so many new information as well, right? So you don't want your question, the user question is getting manipulated. Okay, you want user question to completely like unchanged. Okay, so that next time if you do the chain.invoke method, so that will not get easily manipulated by the other set of attached attributes like the prompts, like the LLM, right, the other instruction as well. Okay, so that is why it is always better that while creating the chain, right, while creating the chain, always like try to specify this runnable pass through. Okay, so this is the one thing that I wanted to like show you. The other thing is that while making the memory, okay, while making the memory, these parts, see this one, yeah, runnable with memory history. See, till now, in order to attach the functionalities of memory in your chatbot system, you have understood about that either you can just specify some kind of a in memory space, okay, or you can actually use the conversational buffer memory or conversational buffer memory window. Okay, but these things are basically is not very good for production based environment. Okay, because these things are already like depreciated by langchain, okay, in the last version. So what people are just using it for now is basically the runnable with the message history. Now what does that means? That you are supposed to save your chat, okay, in some kind of a cache database like the Redis, or even if your Postgres database or anything. Okay, so that while your conversation, like in your present session context, okay, in your present session ID, whatever the conversation that you are doing, okay, all this conversation will getting saved into your Redis, okay, or in a local system, okay, or in some kind of a explicit already defined some data storage. Okay, so this way. So why? Because these things are basically like are more static. Okay, because what happens in the earlier using the buffer memory system, that it was not like, because it is actually we used to pass the entire window attached with our LLM, and then based on the user query, okay, the LLM will get hallucinated. Okay, it is try to give us the more hallucinated response if we going to ask any question related to the previous memory. Okay, so it is always better to have these insights. Okay, that is why it is always good strategy to use this runnable with the memory. See, you will understand these things. So what it will doing is that first of all, it has actually created the chain. I am just using the in memory chat message history and then runnable with message history. Okay, what is this? So first of all, I need to create some kind of a storage. Okay, this storage is actually the Redis or some other database. Now this is basically the get history, like get session history function. Okay, and this actually I have used in my the local chatbot also. Okay, and why this strategy is needed, I am actually telling you. See, first of all, while creating my chain, right, so I am actually use this runnable with the chat history message, okay, which I have actually imported it from the LangChain core chat history. What it will do is that by passing this chain, okay, I am also passing the get session history, which means that whatever the user is supposed to ask now, okay, or the previous conversation, I am actually passing it here, and where this previous conversation is actually saving in some storage. Okay, for now, let's say my storage is just an empty dictionary. It can be your Redis as well as your even local server as well. Okay, with that, I am also passing the user input, like whatever the user input message is there, and then the previous history message. Okay, now this is very good because see, suppose if actually he is asking a question, I can actually attach my session ID. Okay, and with my session ID, suppose the next question, if I'm supposed to ask, it is supposed to give me the good response. Okay, so this is actually the very good way, and this is like the very latest way. Okay, see, even if I like ask the same thing, right, see, the next question which I already asked is that, so like which one should I use? Should I use the runnable with the memory history, or should I use the conversational before memory history in my production chatbot? So it has given me that in 2026 you should use the runnable with the message history. Okay, why? Because the last these two are already been depreciated, because many public are actually like complaining about the hallucinatory response, right? So that is why just LangChain that has actually like depreciated these things, and they have actually like improvised it and improve it using the method which is called the runnable with the message history. Okay, so please understand these things. Okay, so what you have understood till now is that, so you have understood about these two things. Okay, the first thing is that you have understood about the runnable pass through. Okay, runnable pass through is basically like making the very clean set of information not been manipulated by the other set of attached input, okay, in the chain. So you should use the runnable pass through, and then there is something called a runnable chain memory. Okay, why is it needed? It is just a replacement of your the earlier what we used to use the conversational memory. Okay, so it is always useful. So these two things I wanted to tell. Anyway, I will try to make a separate notebook to make you understand about all these things, but I was thinking that maybe you could understand in this lecture only. Okay,